This is Himanshu Suryavanshi from Ramdev Baba University. Today we learn about classical and quantum billiard ball of quantum computing. So let's start. Classical and quantum billiard ball example introduction. The billiard ball example is used in physics to show the difference between classical and quantum mechanics. In both cases, a small particle is assumed to move inside a closed boundary, but its behavior is completely different in both cases. Classical billiard ball concept. In classical mechanics, a billiard ball is a solid particle moving according to Newton's law. Its motion is fully predictable if we know its initial position, its initial play velocity, its direction of motion. Classical motion. The ball moves in a straight line on hitting a wall. It's deflects with the angle of incidence equal to the angle of reflection. Energy remains conserved. Directed graphs and adjacency metrics are used to predict the outcomes in future events. Features of classical billiard. Its nature definite particle position exactly known at any time, path well defined straight line, motion fully predictable, laws used Newton's law, energy can be calculated easily. Classical deterministic system. We see a graph on which there are six vertices, each vertex having some amount of marbles through which we find the initial state adjacency matrix, and then we take a product of them to find a new matrix which gives us the new position of marble at different places. So at vertex 0 there are 6 marbles, at vertex 1 there are 2 marbles, at vertex 2 there are 1 marbles, and so on. So for the initial state, for initial we need matrix. There are six vertices, so we need to create a 6 by 1 matrix. So at 0 vertex, there are 6 matrices, so here we write 6. At 1 vertex, there are 2 matrix, two marbles, so here we write 2. At vertex 2, here is a 1 marble, so here we write 1, and so on. Adjacency matrix. Here we need to find the transition line. So here we need to create a matrix of 6 by 6 vertex. 6 by 6, there are 6 vertex. So we need to create a 6 by 6 matrix. So we need to find the transition from vertex to the another vertex. So from 0 to 0, there are no transition going. So here we write 0. From 0 to 1, there is also no transition line going. So here we write 0. From 0 to 2, there is also no line. So here we write 0. From 0 to 2, there is also no line. So here we write 0. From 0 to 4, there is also no line. So here we write 0. But from 0 to 5, there is a line specified. After a certain time, 6 marbles are going to the vertex 5. So here we write 1. Similarly, from vertex 1, the line are joined to the vertex 2. So after a certain time, 2 marbles are going to the vertex 2. So here we write to 1. So from vertex 2, there is a joint line to the vertex 4. So here we write 4. Here we write 1 against 4, and so on. After multiplication of adjacency matrix and initial state, we get a new matrix which gives the position of marbles. So at vertex 0, there are 0 marbles. Initially, there are 6 marbles. At vertex 1, there are 0 marbles. Initially, there are 2 marbles. At vertex 2, there are 9 marbles present, but initially there are only 1. So let's take another example in which there are 6 vertex 0, 1, and 2 with marble at vertex 0, and this give us the probability. So let's find initial state. So initial state will be 1, 0, 0 because marble is at vertex 0, not at vertex 1 and 2. So here we write 1 at vertex 0. So adjacency matrix. For adjacency matrix, there are 3 matrices, so we need to create a 3 by 3 matrix. So we need to see a transition. From 0 to 0, there is a no matrix, so here we write 0. From 0 to 1, there is a line. So from 0 to 1, there is a line of probability 1 by 2. From 0 to 2, there is also a line of probability 1 by 2. And from 1 to 1, there is a probability of 1 by 3. From 1 to 0, there is a probability of 1 by 3. From 1 to 2, there is a probability of 1 by 3, and so on. After one time click, And that means after a product of adjacency matrix and initial state, the new position of marble will be this. At vertex 0, there will be no matrix. At vertex 1, there will be half chance. That means 50% chance of marble going to the vertex 1. Similarly, at vertex 2. Quantum billiard concept. In quantum mechanics, the billiard ball is replaced by very small particles such as electron photon. In quantum mechanics, the particle behaves like both a wave and a particle. It's described by a wave function. Its motion is governed by Schrodinger's equation. So let's take an probability nature. The exact position of the particle cannot be known. Only the probability of finding it at a certain position can be predicted. Feature of quantum billiard. Nature, wave particle duality. Position, only probability is known. Path, no definite trajectory. Motion, described by wave equation. Laws used, Schrodinger equation. Energy, quantized discrete energy. So let's take an example. Here we see three vertex and a marble is at vertex 1. So for this we need to create an initial state and adjacency matrix, then product. So in classical system there are the probability in real numbers, but in quantum probabilistic system there are the weight in the complex number. So here we see vertex initial state. So initial state will be 100 because at vertex 0 there is only one marble. There is a marble. At vertex 1 and vertex 2 there is a no marble. So here we write 00. Adjacency matrix. So here is a 3 vertex. So we need to create a 3 by 3 matrix. So we need to see a transition from 0 to 0. There is a 1 by root 2 weight. So here we write 1 by root 2. From 0 to 1 there is a minus iota by root 2. So here we write minus iota by root 2. From 0 to 2 there is a no weight line. So here we write 0 and so on. The position of marble after one time click will be at vertex 0 there is a 1 by root 2 chance, and at vertex 1 there will be minus 1 iota by root 2. At vertex 2 there will be no marble chance, so there it will be 0. So comparison between classical system and quantum system. Classical system, weights are in real numbers. The system does not return to its initial state. It is deterministic. Position can be known exactly. While in quantum system, weights are in complex numbers, the system returns to its initial state. It is probabilistic. Position can be probability only. Next, conclusion. Classical billiard is deterministic and predictable. Quantum billiard is probabilistic and governed by a wave behavior. So here we see the topic classical and quantum billiard balls. So we here stop. Thank you.